Hi everyone, this is the last page of the Unit K exam review packet, and all of the questions on this page have to do with what was called the fundamental theorem of similarity. So I want to take a second and review the things you did at the beginning of this packet to help you realize the difference between the first few problems in this packet where you were just setting up a nice easy proportion and these problems that we were about to do. So thinking back to question number 1 from this Unit K review, it said you have a photograph that is 5 by 7 and you want to enlarge that photograph so that the shortest dimension of your new photograph is 10. And the question asks you to find what this other length is. Okay? Hopefully to do this, you just set up a proportion. You just said 5 over 7 equals 10 over x. Okay? And then you solved and found that this new x was actually equal to 14. Okay? And you're allowed to do that because in this situation, you are comparing length with length. Okay, both of these items involve just length. Now, when you're comparing length with length, you have something called a K value. And the K value is what you have to multiply by to get from one figure to a similar figure. So in this case, our K value was 2, because to enlarge this photograph, we had to take this 5 and multiply by 2 to get 10. Okay? Let's say that instead of comparing length and length, you were comparing length and area. So maybe they tell you that the length in one photograph is 5, the new photograph is 10, and then it says, how does the area of the old photograph compare with the area of the new photograph? Well, when you're comparing length with area, it's not this clean anymore. Okay? When you're comparing length with area, the overall value increases by the K value squared. And if you take it a step further, if you start comparing length with volume, the overall value increases by K cubed. So you may want to look back in your notes on that section to understand why that is, but I just wanted to point out that the questions we're about to do on this last page cannot be done with just a simple proportion, because it's not just a single K value that you're working with anymore. You're working with either K squared or K cubed. Okay? So let's see if you can figure out what I mean here. A hexagon has an area of 90 square inches and the shortest side length is 5 inches. A similar hexagon has a shortest side length of 4 inches. What is the area of a similar hexagon? So we are comparing area and length, which is where that K squared is going to come in. The first thing we need to find is what K actually is. K is what I have to multiply the old side length by to get the new side length. So I'm saying to myself, 5 times what K value would give me my new side length. To find that, I'm just going to solve this equation. I'm literally asking myself, 5 times what would turn into 4? Because that's what I want. I want 5 to turn into 4. To solve this, I would just divide by 5, and I would find that K is equal to 0.8. So the area, to change this area to my new area, is going to get multiplied by this K value squared. So my new area would be the 90 times the 0.8 squared. And again, that's that K squared thing we were talking about a second ago. Okay, 90 times 0.8 squared is 57.6, and that would also be in square inches because it's an area. Okay, so again, you would not be able to just say 90 over 4, or sorry, 90 over 5 equals x over 4. That would not work in this problem because you've got to get this k squared in there somewhere. So something similar is going to happen in number 14. An octagon has an area of 150, longest side length is 10. A similar octagon has longest side 4. So we want to turn a 10 into a 4. All right, that's the direction that we're moving in, a 10 into a 4. So I'm asking myself 10 times what k value would give me 4. To solve that, let's divide by 10 on both sides. And I get a k value of 0.4. And then my area, the 150, is going to get multiplied by k squared because it's area. So 150 times 0.4, squared is 24. Oh, and that would be square centimeters. Whoops, sorry about that. Again, make sure your answer makes sense. We started with an area of 150 and it got significantly smaller, but that makes sense because we went from a side length of 10 to a side length of 4. So that does seem to make sense. Okay, number 15. A 16-inch pizza costs $9.50 at the same cost per square inch. And so this right here, the square inch, tells me that I'm thinking about the area of the pizza. What should an 18-inch pizza of the same thickness with the same ingredients cost? So really the issue here is that when you make that pizza bigger, you've got a bigger area that you have to cover with toppings. So I want to turn a 16-inch pizza into an 18-inch pizza. You're always looking for two lengths to go together. And so I would say 16 times what k value is equal to 18. Let's divide by the 16. And I end up with k equals 1.125. And so then that price, because that price is based on the area, needs to change by this value squared, because the area is going to get bigger by this value squared. So I would say 950 times 1.125 squared. And I get kind of a crazy decimal, but let's remember that this will be money. So I would say, and I keep shorting myself on space here, but $12.02 would be the price of the 18-inch pizza. Okay? It takes 3 tubes of gold paint to cover a cube with edge length 2 inches. How much gold paint will it take to cover a cube with edge length 4 inches? Now, we didn't talk about this specifically, but it's very similar to what we've already done. If we are covering a cube with paint, really what I'm talking about there is surface area. But remember that surface area is just an extension of area. It's just a different type of area problem. So even though you're dealing with a three-dimensional solid here, you're not talking volume because you're not filling the cube with paint. So you're still just covering the surface. This is still a volume problem, meaning we're still going to use the k-squared method that we did up above. So I would say, all right, my old edge length was 2 inches. And I want to turn it into a cube that has an edge length of 4 inches. So that one's pretty obvious. My k value here is just going to be 2. Okay. And so my overall area is going to increase by 2 squared, meaning I need to take my 3 tubes of paint, multiply by 2 squared, and I end up with 12. 12 tubes of paint. Because the area would be 12 times larger. I'm sorry, the area would be 4 times larger, and 3 tubes of gold paint would cover the 2-inch cube, so I would need to get 4 times larger with my number of tubes. Sorry, I misspoke there. Okay, a figure with area 16 is transformed into a figure with area 64 under a size change of magnitude what? Okay, here's where we need to be careful. Because I'm comparing areas here. And remember, areas change by a factor of k squared. That's really what this is. Remember, this is my k value, and I squared it to change one area into another area. So when I'm trying to figure out my k value here, very important for me to say 16 times something squared would have to be 64. Okay, so my k value is not just 4, because 16 times 4 is 64. My k value has been squared because I'm dealing with areas here. So when I solve this, I would divide both sides by 16. I don't have a ton of space here, but I would end up with k squared equals 4. And again, I got that because 64 divided by 16 is 4. And then I would have to take a square root of that to find that my k value is actually 2. Okay, so this is kind of going backwards from what we did up above. If you look even at number 16 here, when my k value was 2, I ended up multiplying my area by a factor of 4. Okay, so that's what's happening here. I'm multiplying area by a factor of 4, which must have meant that my k value is actually 2. Okay, if it takes 1,200 gallons to fill a cylindrical swimming pool, how much would it take to fill a similar swimming pool with double the radius? Okay, so right here, this tells me that my k value is 2. Because remember, what your k value is really telling you is how did the radius change, or how did the length change, to be a little more general. So how did the length change? The length is doubling. If you're filling a swimming pool, that's volume. So volume deals with k cubed. So I would take that 1,200 that it took me before and multiply by my k value to the power of 3. And I believe that should come out to be 9,600 gallons. Let me just double check that math quick. Yep, that'd be 9,600 gallons. So again, I use my k value cubed because we're talking volume here. Okay, one more. When his height was measured at 8 foot 11.1 inches, Robert Wadlow weighed 439 pounds. How much would a 5 foot 10 man weigh if he were in similar shape to Wadlow? Okay, weight, again, is really a volume because it's a measurement of how much mass you are taking up. Okay, it's a measurement of your total body volume. So we're going to again be using k cubed, and we need to find our k value between this height, and remember height is just a length, and this height. First we're going to need to do some conversions here though. And you can decide if you want to put these into feet or into inches. I think I'll probably just go all into inches. There are 12 inches in a foot. So in that first problem, 8 times 12 is 96. And then I'm going to add on the 11.1 inches. That's going to be 107.1 inches for Wadlow's height. Okay, so that's really this. And then the 5 foot 10 man, 5 feet times 12 inches is 60. And then I'm going to take that 60 and add the other 10 inches to get 70 inches. And that's really this, the 5 foot 10. Okay. Now let's find my k value. So we want to turn this height into this height. Okay, because I'm comparing this guy to this guy. So I am saying 107.1 times what k value would give me 70. To solve that, I would divide by the 107.1. Divide by 107.1. That's going to come out to be, I'm going to round that to 0.654. You don't want to round too far, like I wouldn't round all the way up to 0.7, but probably 3 decimal places is safe. And then again, if we're talking weight, weight is really a volume measurement, so I want to take my old weight and multiply it by my k value cubed. So I'm doing 439 times 0.654 cubed, and that's going to give me about 122 107.8 pounds. Okay? Which again is reasonable for the weight of a person. So, hopefully that made sense. The one thing I see a lot in these problems is people wanting to take the shortcut and not write out this step. They want to just start dividing. If you take the time to write out this step, you won't get confused about, do I multiply to get this answer? Do I divide to get this answer? Which direction am I changing in? If you think to yourself, this is where I'm starting, and I want to change into this one, you can write it out this way, and it will solve for the K value correctly. If you found the K value the other way, if you had divided 107.1 by 70, that would mean you would need to take this and divide by your K cubed. But if you don't want to worry about keeping that straight, I would always just set up your equation like this. Okay? Hopefully that made sense. Otherwise, please feel free to ask in class if you still have questions on that.